right, so I call this one. So we created an AWS SDK. We call it AWS-lite. If you'd like to follow along at home on the website, you can hit that at aws-lite.org. So in order to explain AWS-lite, I have to talk a little bit about my company, Begin. We're not going to get too vendory today, but it will help elucidate why we arrived at creating our own AWS SDK. So Begin creates what we call functional web apps, which are totally serverless Lambda-based web apps. And you can learn a little bit more about the FWA idea at fwa.dev. And the way that it works is every web route has its own dedicated Lambda. So your get foo route maps to source HTTP get foo. And every Lambda has to be really fast because this is all customer hot path. So by default, FWAs that are provisioned with Architect and Begin use a variety of services in the AWS ecosystem like Dynamo, SNS, SQS, and many more. We were doing that for a super long time with the AWS SDK, as you might expect. Back in late 2021, we started to observe some unacceptable cold start latency that really caught our attention. We were seeing simple operations in these customer hot paths on the web taking over a second. Over a second to load a web page because of SDK calls was not acceptable to us. So we started tracing it and we found it was the AWS SDK. We found that to be really surprising because our expectation was just that we could always rely on the AWS SDK to be performant. So back then, Amazon, when we brought this up to them, advised that we do a deep require of a given client. So if we wanted to use DynamoDB, don't require AWS SDK. You could actually require AWS SDK /client/DynamoDB. This is more common knowledge now, but back then it was not really widely known. And that did improve latency for us. So we saw some improvements. So flash forward a little bit, SDK v2 is deprecated, and we're all told we need to move to SDK v3. Probably a lot of people watching this are still mid-flight in that transition. And there was just another problem, which was, once again, the client was creating extremely long latency, unacceptable latency for these customer hot paths. So we had this major performance regression upon switching SDK v3. And again, this was made really abundantly clear that we were not going to be able to get around this. Amazon is shutting down SDK v2. It's not going to be available in Lambda in July. You have to move to SDK v3. And just a little bit icing on the cake, if you have not recently gone to the SDK v3 docs, well, gird your loins. They're difficult, to say the least. So I remember this old Alan Kay quote that I really liked, which is that people who are really serious about deploying to AWS should make their own AWS SDK. Just kidding. Obviously, Alan Kay never said that. And I really want to underscore the point. We did not want to do this. I did not want to spend my time building an AWS SDK, but we really did not feel like we had a choice. We believe in Lambda-based workloads, and we believe in web apps that are dynamic and powerful and built with Lambda, and those need to be able to talk to AWS services quickly. So we decided to build our own, and we called that AWS-lite. It is Node.js specific for right now, and that is really important because the AWS SDK that Amazon makes is intended to be used in a variety of environments. We don't have that requirement. We are shipping for Node.js. And because we're doing that, we can make it super fast. We can really hand author the code, make sure it's not only readable but performant, and because we care about open source, we can make that a community-driven project. So let's talk about speed. This is one of the biggest reasons why we did this. It's not the only reason why we did this, but we felt that this could be done faster, and it is. So we published benchmarks. When I was first bringing up the project, I put a lot of time and effort into a benchmarking suite. We didn't want to just make claims. We wanted to be able to prove with science, no smoke and mirrors, just how much faster this stuff is. So in this chart, you can see a time to respond with a single DynamoDB round trip is about twice as fast with us. And one of the cool things about this is compounding. So the more complicated your backend is in Lambda, the more time you will save using AWS-lite. But you don't have to take our word for it. Like, we are seeing this in the real world. This isn't just a synthetic benchmark thing. I love this post from Phil, who showed what happened when he cut over his recurring Lambda executions. He had a scheduled job that he was running that would take between 15 to 20 seconds, and suddenly it reduced by half the Lambda durations. So not just about benchmarks. This is real. But it wasn't enough to stop with speed, because I work in the AWS SDK all the time at Begin, and I have to use this stuff. So it needs to be ergonomic. So one of the things that I really wanted to have in this was a nice debug mode. So you can watch requests and responses flowing through the system as you're using the SDK. It's got a fully pluggable API. So if you don't like the way that we have structured our service plugins, you can make your own. You can also make your own for your own make your own plugins for your own services. So AWS SDK not only is compatible with AWS, but it can be used with services like Backblaze, or in theory, any other AWS compatible API. And there's a growing number of those. As a first-class concern, we handle automatically the serialization and deserialization of AWS flavored JSON. If you know what that is and what that means, I'm sorry. But if not, it's really nice, and it's just not a thing you have to think about or deal with. We have unit test integration that is totally generic. You can plug this into any unit test system or setup, and be able to define mocks and responses really easily. And I think our docs are pretty good. I mean, there's always room for improvement, but I think they're all right. Yeah, I'm not trying to like brag here, but I think they're pretty decent. And then I wanted to talk a little bit about what openness means to us. So openness isn't just, is the source code published on GitHub, which of course it is. But if you've ever looked at the AWS SDK, everything is built and generated. It's very hard source code to navigate. It's all meta code. So we have zero abstraction built resource. If you are curious about how it works, you can just dive right in. This is really simple, low-level stuff that we think is really important. We have an @types like contributor model. So we encourage people to come in. If you have a service that you really rely on in the AWS ecosystem, you can volunteer to maintain a service plugin. And again, if you don't want to do that, you can maintain your own. Everything is licensed Apache 2.0. Our service plugin surface area and the number of methods that we support is growing rapidly. And we try to do everything out in the open. So it's all on GitHub, it's all on Discord, and we welcome PRs. So openness is a big part of this. AWS is a gigantic ecosystem. We're not going to be able, as a small company, to cover everything ourselves, and nor do we intend to. So we really do rely on external contributors to come help make this project better. So with that, I'm going to just do a little bit of hacking with aws-lite on my computer here. We can see it do some stuff, and then let's go to some Q&A afterwards. I find that most of the interesting stuff seems to happen when people start imagining a world without the AWS SDK or beyond the AWS SDK. So I want to leave plenty of time for Q&A if possible. So here I've got my demo project. There's nothing in it except two dependencies. I've got the AWS-lite client and the DynamoDB plugin. So I'll just create a new file here. Import AWS-lite. And let's get going. So the first thing I'm going to need to do with AWS-lite is instantiate it. So I will do I'm going to set the region US West 2. That's the one I'm going to be interacting with. You do have to specify a region. It will also pick that up in your AWS configuration if you have that set. This is going to use my default AWS credentials, so I don't need to specify those here. And we're going to specify a plugin. That will be DynamoDB. So, and then over on this side, I've got a little script that will just continually refresh in the terminal every time I save and make a change. So if you're wondering why the terminal is just going to be constantly changing, that is why. I call it TRR. If you ever want to use that, it's on NPM under TRR. So I'll just go ahead and hit that. Oh yeah, don't forget you have to install your packages. There we go. Cool. So let's go make our first call. So I'm just going to do a DynamoDB scan here, and I'll do a table name. I think that is the table name that we're going to scan. How do we look? Cool. So I'll just explode that a little bit better. So this is the resulting scan of the DynamoDB table name I specified here. So it's got one row. ID of food, data, okay, true. Pretty straightforward. Now let's see what happens if we actually kind of go under the hood and turn on debug mode. This is something I use all day long, every day, it turns out. So here, once we get it going, we see client instantiation information. What's the current configuration? What are the methods available? We've got my credentials. We redact your keys just in case. And then we actually publish the raw request here. So you can see what's going on under the hood. In this case, not a lot. It's just a pretty simple request because it's a GET. And the response, you see, we've got the AWS flavored JSON that I referred to earlier. Now, this is not my favorite to work with. So when I started on this project, wanted to make sure that this came out a little more workable. In AWS SDK land, you have to instantiate a document client. There's a whole bunch of redirection that happens around there. Here, we just give you the data as you would expect it to be. So you can see that right here. So let's see what happens when we want to write a row. So I'm going to put a new item, table name, got an item. So I'll specify the ID of bar, since my primary key on that table is ID. And then I'll just do another data property, and I'll call that, okay, false. So now I've got two rows. Pretty sweet. And then again, we've got the whole request response cycle going on over here. You can see my published new row to the put item method, and then the response and the request from the scan and the response for that. And here we go. Now, let's say I actually wanted to implement this as part of my business logic, and I wanted to have some control over this whole cycle in my unit or integration test suite. So we can actually do that with aws-lite's built-in testing API. So what I'll do here, so I'm going to disable that, and I'm going to turn on the testing mode. So in order to do that, I do aws-lite testing.enable, and that turns on testing mode. And so when I do that, this scan is not going to find anything because I turned on testing mode and didn't specify any mocks. So I will go ahead and do that now. So the first property that you specify in a mock is the method name. So I want to say this is going to be my response for a scan. And I like the way that that looked up here. So let's say my business logic really only cares about the items array. So I'll just go ahead and specify the items array. I'm not going to worry about the count property or the scan property or the scan count property. And then I'll do hello and whatever. Okay. I'm going to turn off debug here because it's not really going to add a whole lot of value in the testing mode. But now you can see that my scan that I had done down here on live AWS is returning the data that I specified here in my mock. And what's also kind of neat, let's get rid of that for now, is I can do this sequentially. So say your business logic has multiple operations on the multiple scan operations as it progresses. You can set up multiple responses in sequence. So I'll turn this into an array. Format that here so I can see what I'm doing. So my first scan is still that hello, okay. And if I run this a second time, you see the second in the sequence. So this allows me a lot of granular control over how AWS requests and responses are tested. This is a first-class consideration of AWS-lite. It's not something we farm out to, and it's baked really low level into the system, which is nice because there are some tools out there like the AWS SDK mock, and there's a V3 mock as well. Those use systems like sign-on and other mocking tools under the hood that are, in my opinion, a little complex and somewhat brittle. So again, this was something we wanted to make like a really nice first-class consideration. And then if I'm good, say I just want that for the first request, I can disable it. So then I've got my mocked response for the first time around scan, and then I disable testing, and it goes right back into talking to live AWS. So yeah, AWS Lite, super fast, open source in, I hope, a meaningful way, and integrates nicely with your testing systems, and highly extensible. So that is the project that I've been working on lately, and I would love to answer questions about it.
Thanks, Ryan. That was great. We've got a few questions waiting for us, and folks out there in the audience, keep using the questions tab and dump your questions in there. I will filter them, and we've got about 20 minutes or so to chat here. So I've got a couple already lined up from Brian, and let's start there. Brian asks, what are the key differences that enabled you to get such a significant performance difference?
Yeah, so because most people are just consumers of the AWS SDK, and we don't spend a lot of time kind of getting into the weeds there, you don't really notice how it was authored. And basically, the AWS SDK is authored almost entirely in metacode. And I have like a kind of an interesting real world example that speaks to the differences between the AWS SDK and the AWS Lite. So the reason why AWS authored their SDK in metacode is because they have some requirements, I think. They have some requirements that we don't. They wanted to automatically publish types. They wanted a system that could be used in browser as well as Node and possibly in other JavaScript environments. We don't need to do those things. We're actually drafting on their types, so that's really nice when we thank them for publishing those types so we can make use of them. And we're not targeting the browser. So we can write real JavaScript. And so the way that this metacode kind of nets out is the example I would give is AWS's CDN system is called CloudFront. And CloudFront is an older system in their ecosystem and utilizes XML, like deeply, deeply nested XML for all of its requests and responses. And writing a metacode system to handle the validation and publishing of super deeply nested XML from JavaScript, and interpolating that into XML is quite tricky. And when I was going through and creating our plugin for that, I observed that there was something like 10 to 12, I think, thousand lines of code for handling this deeply nested structure. When I authored it by hand, which was quite annoying. I mean, I'm not going to lie, it was not fun to do. My implementation was about 200 lines of code. And so, I mean, maybe there are some bugs in there. I don't know. I have not seen them. I use it. So, you never know. There could be bugs in their system as well. But if you're comparing like my 200 lines of code ish to their 10 plus thousand lines of code, this is why, in a nutshell. So yeah, we write code the old-fashioned way with ChatGPT. Just kidding. We write it by hand, and it's really fast. Is kind of the condensed answer.
So you said you take advantage of their TypeScript library, which is great because one of the questions I had was, did you put an emphasis on having parity in terms of method names so that is it like are you matching those names for what you've included in AWS-lite? So it's, is it easy to move from one to the other, or did you take your own approach on the SDK design?
Yeah. So for the first, we call them like the first class plugins, the ones that we publish. Those ones we use SDK, AWS SDK semantics for. So we use their method names. We try to use all their property names. Occasionally, there are things that we do to improve upon them, and we have the ability to kind of denote those in the types that we publish. But for the most part, we just kind of re-export all their types because we can. We're following their semantics. So part of that is so we can draft on their types, which is nice. This project would be almost impossible for me to maintain both the all of the API integrations as well as types for them. But it allows us the ability to focus really solely on just the logic. So all the type stuff, like if you use that, great. It's there for you. If you don't, no worries. We've got pretty good documentation that gets generated from the stuff that we do, that we do already maintain. And yeah, so I hope that answers the question.
Yes, definitely.
Okay.
Another one coming in from Brian is, are there things that I cannot do with the AWS-lite SDK that I would have to use the full AWS SDK for?
There's not many. I mean, I think it really just depends on the services that you use. So if you use the AWS SDK for a service that we don't yet have a plugin for, and you don't want to author your own, we do have an escape hatch for that. Actually, we have a low-level client that allows you to just interact with any AWS service without having a plugin, which is nice because if you we sometimes see this in our work. We bump into something where we don't have a plugin. We just need like a single method. So we just like do a raw request with AWS-lite. We're done. It's good. So if you don't want to use that escape hatch, if you want to have like all the nice, pre-built semantics of the AWS SDK, that might be a thing. It's still also fairly early. The library has been around. We just introduced it late last year. So for certain things in, for example, what is called the AWS credential provider chain, we don't yet have full support. AWS has a system called IMDS in EC2. If you use EC2, I mean, this is more serverless, so maybe you do, maybe you don't. But we don't yet support IMDS. We will. We don't right now. So there's like edges like that. But Generally speaking, I think if you are working in serverless, AWS serverless specific workloads, it will probably cover most of your normal day-to-day use cases.
But it sounds like do you have some level that you have to get to? I'm thinking if you're going to spin up a plugin for a new service, um, are do you have some threshold where you're like, well, the MVP is, X% coverage of all of the methods that AWS SDK offers, or are you going all the way, or does it just depend on the situation? It depends has been a theme today, so
Yeah,
that's
I
okay.
think it depends. I think for the most part, this might sound kind of like, I don't know, self-serving, but it's really like last night, for example, I was working on something for the AWS-lite performance project, which is like this adjacent project that does all of our benchmarking and scoring for this thing. So we have something to compare it to. And I needed a plugin for AWS IAM, and it didn't exist. And I was like, well, I'm just trying to get something done here. So I wrote, I authored like the 4 methods that I needed, and I published it. And so like if you use IAM and you went to AWS-lite, you'd be like, oh, this only supports like 4 methods, and these are not even the methods I use. So like that's totally fair. That would be a completely fair criticism, and I will take that one on the chin. But it's also like let's not let the perfect be the enemy of the good. And we encourage people if you need more methods, like send us PR. It's all there. We'll take PR from anybody. Just sign the CLA.
Yes, great. So yeah, and speaking of that, I'm curious. I mean, you mentioned that there's obviously this massive landscape of everything that you would have to support if you were going to support all of the services, but there's also, so many other tasks and places to spend your time when you are supporting an open source project. And so I'm curious with it's a big project to take on. How do you approach balancing and prioritizing your time so that you're also able to get the work for begin done, but keep this project moving forward?
Um, yeah, I mean, I think it kind of takes care of itself insofar as it's got very clear priorities. So like, we had a bug report in the last week where something was pretty badly broken under certain circumstances. And that was a pretty easy decision, right? Like, oh, I need to fix that. We prioritize bugs first at our company, like culturally, we drop what we're doing to focus on important bugs. So I did that. Most of the time, I don't really see that in AWS-lite. It's been very, very stable. And yeah, so I mean, if PRs come in with new methods or new plugins, we triage those, within a day or two. But the project is still young, and we're not inundated, so it hasn't really been a huge problem. Over the fullness of time, as the project grows, and it has been growing, and usage has been increasing, I'm sure this will, become more of a problem, and then we'll start to have to designate additional people to contribute and work on it. But we're just trying to solve one problem at a time. So
Okay, yeah, that makes sense for sure. Back to the performance for a minute. So you had mentioned when Brian asked about the performance comparison, you mentioned that the pure quantity of code was one piece, and the other piece being that you're able to focus on and target just Node. I've seen of different approaches and people kind of introducing different languages to try to make things even faster. Like there's been a lot of talk about Rust over the last couple of years, and so I'm curious if you've thought about other ways to improve performance, or if you're getting what you need from Node, it's good enough, it's solving your problems, and you're going to continue down that path.
hmm. Yeah, I mean, um, I if there's a thing that we can do at all ever with AWS Lite that will increase performance, like I will do that thing. So just as an example, I created an issue this morning for myself. We have two dependencies, and this is part of the performance as well, like minimal dependencies. And those dependencies have no sub-dependencies. We rely on Michael Hart's AWS 4 for signing the requests, really great library. And we rely on INI for reading the AWS credentials files on your local machine. We have to extract the credentials in order to make the requests. The INI dependency is 20 kilobytes. I think we can probably do that in 10 to 20 lines of code. Is that like a gigantic savings? No, but like it's easy, right? Like that's not like a challenging thing to do, and it removes a dependency, removes file reads. It's all incremental. So I am open to any performance increases that anyone has. I think there's like no performance increase too small. We don't use things like Axios or anything for HTTP. I use the raw Node HTTP built-ins. So everything we do is performance optimized. Yeah, if there's a thing that we can do in Node to make it faster and more efficient, I will do that thing. So I try, like, this is as I'm maintaining it. If I see something, I will try to do it. If I haven't seen it, I want to hear about it. So part of the reason we talk about performance log, we want to put people in that mindset. So if you're an open source contributor and you're looking at it and you're like, oh yeah, this part of the project could be optimized better, like totally, I'm all about it.
And you said that the official SDK also is supporting the browser. Have you had requests come in for that, or is that a place where you're like, no, I'm drawing a hard line there because I know that's gonna totally bloat performance?
Yeah, I mean, I'm not really sure what the browser use case is outside of AWS's own console. I think they may be the primary and possibly only user. So the problem with the browser is you're interacting with AWS services. In order to do that, you need credentials. You're not going to send your AWS credentials to your customers' browsers. You're not going to do that. Like interacting with these services requires a trusted backend process. Yeah, browser is not really a consideration for us. We have had requests for Deno, and we have tested it, and it does work in Deno really well. We have a little bit of a blocker right now, just in order to get the Deno support stood up. But as soon as we get past that with the Deno folks, we'll probably publish a Deno version on JSR. And I will also say, even if you don't use AWS-lite, it's been kind of cool to see AWS respond to the existence of AWS-lite. And I've seen this in the AWS performance project where for the things that we benchmark, especially, specifically the DynamoDB client, their times keep going down a little bit. Like a little bit, as the months have gone by, they've gone down. Like it used to be consistently like our most important benchmark used to have them consistently over 1200 milliseconds. And I think they recently broke 1000 milliseconds. I think it's like the high 900. So they are making improvements because we're out there pushing them. And so if for no other reason than that, I think it's, helping contribute to the ecosystem.
Yes, that was a question I had was, have you talked with AWS at all? Is there, and maybe another way to phrase this is, what does success for this project look like? Is it AWS adopting it? Is it just the official SDK getting better? What are the goals?
Well, our goals are we needed an AWS SDK that we could rely on not breaking us, and that was fast. And so the transition from V2 to V3 was pretty violent for us because all of our code that we had written in Lambda that would rely on AWS SDK V2 now had to be reauthored. From the begin side, from begin.com side. And so that meant a ton of unplanned work that provided absolutely no value to our business or to our customers. And that sucks. So philosophically, an approach that we've always taken with our open source is we don't break people, or if we do, it's minimal and as infrequent as possible. So like a hard break where we're telling all of our customers you have to completely alter your business logic is pretty unacceptable to us. So having a really stable position to build against AWS moving forward was pretty important to us from a business standpoint. So from that perspective, we've already achieved our objectives. We now have a tool where when something comes up and we have like a method that we need for begin.com, if it doesn't already exist, we build it. And if other people benefit from that, great. And if other people want to contribute to that ecosystem, even better. So from that regard, if like project has already achieved its goals. And so it's good. We're using it in production. Everything's cool there. In terms of like, broader impact, yeah, I mean, if it pushes AWS to do a better job with their work, great. I haven't seen it come forward in the documentation. So the AWS SDK v3 docs are notoriously bad, probably some of the worst I've ever seen in any project anywhere. And I will go to the mat on that one. Like no one will argue with me if you've ever had to use it. It's really bad. It is clearly by machines for machines, not for people. So I won't say that ours is like the best. It's just good enough, I think, I hope, for people to use. So from that regard, hopefully it can be a good resource for people, especially if we're using their semantics. You might even be able to use AWS-lite docs to use SDK v3. So yeah, I think those are the goals. And if along the way people see this stuff and are philosophically aligned with it, and that makes them want to try out Begin, that's cool. But that's not the point. The point was so that we didn't have to get broken by this stuff again.
Yeah, that was another question I had was, it's obviously a lot of work to put into this, and it was solving a problem, but has anything yet positive come out of it other than just being able to continue serving your current customers?
Yeah, I mean, I think it's really streamlined our own development. Things that used to take a while when working with the SDK now don't take as long. I mean, it's a little bit of anecdata, so your own mileage may vary, but I've been working with the SDK, AWS SDK, for a super long time, and I can kind of just do a rough comparison of like, okay, I've got this business logic, it's written in SDK v2, we need to do something with it. And I often find, I don't know if I've ever found this not to be the case, that it is faster to build the SDK AWS-lite, the AWS-lite plugin from scratch to accomplish that than it is to attempt to port SDK v2 to v3 because of how difficult that thing is to use and how poorly documented it is. Some people may find that is not the case, and so that's totally cool, but that has been the case for me. It has accelerated our move off of AWS SDK v2.
Yes. Okay. And documentation has come up a few times, and so that's my final question will be, what have you learned about writing good documentation throughout this process?
I mean, I try to hedge because, I never want to make the claim that it's good. I would let other people be the judge of that. It's tricky, I mean, I have a background also in writing too. So writing that like helps people understand what you're doing from an implementation perspective is really challenging. Being terse is not easy. So we do the best that we can. And if it's not good enough, hopefully people will contribute and send us PRs and stuff like that. But yeah, I think really what it starts from is a human being imagining another human being consuming this thing and going from there. What we have in SDK v3 is sadly not that. It is really a system of types for machines, by machines, for machines. And docs are generated from that. So I think if we can remember that these are tools for humans, code is for people, it's not for machines, that if that's the position we start from, we're all going to be better off.
Love that. All right. Well, thank you, Ryan. Thanks for the presentation, for the conversation, and for the work you've done for the open source community at large. Really appreciate it.